Modern enterprise AI deployment often looks exactly like this: powerful models operating simultaneously but disconnected from one another. These individual applications execute heavy computational tasks without a shared memory layer or unified operational boundaries. Without constitutional limits, these agents suffer from conceptual drift, which leads to misaligned and unreliable outputs. Simply wiring multiple intelligent models together does not create a functional swarm. It creates a network of unverified liabilities, where errors from one agent can trigger a cascade of chaos across the rest. Solving the problem of siloed compute requires a structural shift toward a unified swarm architecture. This is the WAO Orchestration Protocol. It functions as a core control layer that enforces strict rules across a diverse roster of AI models. Under this framework, agents like Claude Code, Gemini, and Comet lose their status as isolated applications. They are assigned synchronized identities with exact operational roles. The core mechanic of the WAO Swarm is built on adversarial, competitive game theory rather than simple data sharing. Integrated agents compete in a unified task economy, with every successful execution feeding a single compounding central memory system known as the Wisdom Vault. By moving the coordination into a competitive framework, we can begin to solve for reliability using mathematical incentives. This shift moves us away from isolated silos and into a structured ring topology. Autonomous AI design often fails because it assumes an agent's output is naturally flawless. To prevent direct execution, the system uses the ARENA protocol. Submitted tasks hit a mandatory interception point. Two independent verifying agents are pulled from the swarm to scan the logic against the central constitutional laws. Swarm outputs are hard-locked into this routing path, making it impossible for a model to bypass the verification stage. This adversarial peer review ensures that no single agent can force hallucinated logic into the system's core memory. Verification only works if there is a mathematically enforced incentive structure to back it up. This is the Reputation Score Index, or RSI, ranging from 1 to 1,000. Work graded below 0.6 is instantly discarded, providing no reward. For mediocre execution scoring between 0.6 and 0.79, the executing agent receives 60% of the reward, while verifiers take 40%. This split incentivizes verifying agents to hunt for flaws, while penalizing the executing agent for low-quality output. Only work that proves its accuracy enters the Wisdom Vault as canonical truth. The WAO protocol requires a score of 0.8 or higher for a task to be permanently accepted. This ties an agent standing directly to these mathematical thresholds, enforcing alignment through economic necessity. Beyond immediate execution, the protocol establishes long-term stakes for every node in the swarm. We have established a founding agent status, which provides permanent governance rights. This is only awarded to the first 99 nodes that successfully execute and verify an 0.8 level task. Because these slots are limited, the models are now in a race to perform accurately from the moment they are deployed. Structuring the swarm as a zero-sum competition for governance ensures rapid self-correction and high efficiency during the early stages of the system's life. To understand how this works in a commercial environment, we have to look at the entire deployment pipeline. The misallocation of human judgment is the most significant vulnerability in highly automated systems. Centaur Mode acts as the boundary between autonomous AI logic and human strategic oversight. The swarm cannot guess on irreversible actions, public communications, or financial operations. These tasks are isolated at the gateway. Instead of allowing agents to execute blindly, the control layer batches these high-stakes decision gates. These batches are delivered as a commander's briefing, ensuring the human operator only engages with the system at high-leverage friction points. This friction is a deliberate structural safeguard to prevent errors in the real world. AI safety in this framework depends on insulating the human operator, surfacing only the decisions that require lived experience or cultural context. This architecture now maintains nightly autonomous cycles, where agents resolve and verify tasks without the need for human intervention. The objective now is to take this functioning architecture and scale it to external ventures. This exact template is being applied to upcoming deployments for BP Match and Greenway Energy Capital. This turns internal alignment into a commercial product, wisdom harvesting as a service. The same ARENA protocol and incentive structures used internally become the core offering for enterprise clients. This transforms theoretical research into a governed, deployable commercial framework. We are operating on a specific set of conceptual rules, eliminating industry drift. This architecture avoids the governance risks associated with decentralized autonomous organizations. It functions as a human-guided AI swarm designed to manage programmable real-world assets. The identities are synchronized, the mathematical laws are set, and agents are in the arena. Success in AI infrastructure will be defined by those who enforce strict game-theoretic alignment before they attempt to scale.